Okay, so for our next task number 3, we're going to start looking at some of the LSP attributes that we can assign to the tunnel. So first we need to configure a MPLS TE tunnel number 2 from R1 to R2 with 3 dynamic path options using the following parameters. We need to use a auto route announce, just like we did on tunnel 1, and here are the list of parameters that we're going to have to configure for the 3 path options. The first path is bandwidth with 800 kbps with the priority. You can see there's 2 values. The first value is what is known as a setup priority, and the second value is what they call a hold priority, and we can see this when we try to configure the tunnel, and it has to be entered in that order. And just to talk about the priority real quick, so when the tunnel first established, it would try to pick the most preferred path, and for some reason if that path has limited resources, or if the tunnel were to set up and the resources will be exceeded, the tunnel is given a chance to preempt the previously established tunnel, and this is based on the priority value that's assigned to the tunnel. So the tunnel that has the higher priority will be able to preempt the tunnel with the lower priority, and the value that gets compared here is the setup priority of the new tunnel, which will be compared to the tunnel that's already established, and that's the hold priority. So if the new tunnel has the better setup priority than the hold priority of the existing tunnel, then the new tunnel will be able to preempt that. And the lower the value, the higher the priority of the tunnel. Now for the affinity, so affinity is basically a way for a tunnel to pick a candidate's path. So by default, all of the link will have a attribute flag value of 0. As what we did in the task number 1, we make some adjustment to some of the link attribute flags. And the way this works is any links that has the attribute flag that doesn't match the affinity value that defined on the tunnel will never be selected in the path. And all of these will become a lot clearer when we actually start configuring the affinity and how we calculate the values. You can see for our path option number 3, we have a question mark because right here down below, we need to choose the affinity value for path 3 that will allow the path to be going through router R1, 4, and then 2. Okay, and all of these paths options will be calculated dynamic. Okay, so let's go ahead and create our tunnel 2 on router 1. So we interface tunnel 2, then IP unnumber loopback 0, tunnel destination 172.16.0.2, tunnel mode MPLS Traffic Engineering, and then tunnel MPLS Traffic Engineering auto route announce. And then since we are using the same priority values for all of the 3 path options, we can set that at the tunnel level, and that will be applied to all of the path options. So priority right here, the question mark, the first value that you need to enter is setup priority, and we already talked about what the setup priority is. That would be 6, and then followed by the hold priority. Okay, so that would also be 6. If you don't set this by default, the tunnel will have the lowest priority, which is the value 7. Okay, then we're going to set up a bandwidth for our path option number 1, and we're going to configure that to be 800. So 800, then we can configure our path option 1, and that's going to be dynamic. So I misspelled the path, so TH and then dynamic. Okay, so what we have configured so far should satisfy all of these attributes for path option 1. Next, for path option 2, we're going to lower the bandwidth down to 300 kbps while the other parameters or attributes stays the same. And we can do this based on a feature call per path option bandwidth override. If you go back to the path option command, let's specify that as number 2. You can see that we have a couple more options that we can do. Lockdown, we already talked about that in the previous video, and lockdown is the way to stop the tunnel from going through a re-optimization. And here we have a option for bandwidth. You can see as far as description, it said override the bandwidth configure on the tunnel. So we already have the bandwidth configure for the tunnel to be 800, and that's the tunnel level. We can easily override that using an option right here, and we say that's going to be 300. Okay, so enter. Now for our path option number 3, okay, we have the bandwidth of 300, same priority, so we don't need to change that. But now for the affinity, so you can see that as part of the command inline as the path option, we do not see a option for affinity, and that's because you have to define those as part of the attribute list. So what you have to do is to come up with a attribute list with the command MPLS Traffic Eng LSP, and then right here you have an option to define your attribute. Give it a name. Let's call it TU2 path 3. Okay, the question mark, these are all the possible LSP attributes that you can define as part of the attribute list. Okay, so here we can define our bandwidth, which is 300. Okay, and now we have to pick the affinity value that will allow path number 3 to go through 1, 4, and 2. So let's go back to our diagram real quick. So for our path option 3, we want to go through 1, 4, and 2, which is the path right here. Make it bolder for the line. Okay, and in order for the tunnel to be able to use that path, we need to come up with the affinity that basically match these two flags right here. Okay, so when you configure affinity, you'll see that there's two parts of that. The first part is the value, again in hexadecimal format, and then there's a second part which is the mask. Okay, and the masks define what bits in the affinity value that really matters, and those bits that matches the mask are what gets compared to the link attribute flag. So for example, here we have, let me bring up a notepad just to help me explain that a little bit. So right now, the link between R1 and 4, we have the flag of 3, and in hex that is 0011. And then for 4 to R2, the flag is 11, and that would be 0001, 0001. And actually, let me put a 40 in front of that. And for us to come up with a affinity values that will match both of these attribute flags, we need to identify the bits that's in common. So what we have right here is the definitely last one. So I can mark that as 1. And then we also have some of the zeros that also in common. So that's obviously not in common. These ones are, and that one is not. Okay. I mean, you can get as the complex as you want, but if you want to keep things simple, and let's do that. In this particular case right here, we can just basically tell the affinity value to match the last bit and make sure those are 1s. So you can come up with the affinity value of 1, which is this, and then we just come up with the mask that only tells that the only bit that matters in this particular value is the last bits. Okay, so the mask would be 1. As long as the attribute flags ends with a bit of 1, then it will be chosen as a candidate link for the tunnel to build the path across. If you're completely new to the concept of affinity, this might be a little confusing to you. We're going to have another example in a little bit, so let's go ahead and configure this for now. So we're going to choose the value for the affinity of 1 and then the mask of 1. Okay, going back to R1, that's going to be 1, and then mask is going to be 1 also. Okay, we're going to see whether or not that works. I think I need the word mask in there, so let's try that again. There you go. And now we can tie the attribute list to the path. So going back to tunnel 2, just do up arrow, see if I can. Okay, right there. Path option number 3 is going to be dynamic with the attribute list name of, let's see what we call it right here, TU2 path 3. Okay, so all those should be in place already. Let's do a show MPLS Traffic Engineering tunnel, and let's see for our tunnel 2 right here. We have 3 paths, and the one that's in active right now is path option 1. And that goes directly from R1 to R3 and then to R2. If we do show another show IP RSVP interface, you can see that the tunnel 2 has made a bandwidth reservation of 800K. And I have to do show route ISIS just to see what it looks like now that we have both tunnels configured with the auto route announced. You can see that it's load balancing traffic between tunnel 1 and 2. So what we have at this point is tunnel 1 that go from R1 to R2 with the auto bandwidth, and then we also have another tunnel that goes from R1 to R2, but this one is using the dynamic path option with the bandwidth reservation of 800. Okay, so just put it down, 800 kbps. Okay, since the first tunnel doesn't really have traffic through it, it still have the bandwidth reservation of 0. So with those two tunnels reservation combined, we're still at 800, which is less than the 1.5 meg reservable bandwidth of that link. So we have yet to exceed that. Okay, so going down to the next section. And now we need to reconfigure tunnel 1 to have the bandwidth of 1.5 meg. Okay, and we're going to have to allow tunnel 1 to preempt tunnel 2, because obviously if we increase the tunnel 1 bandwidth to 1.5, we're going to exceed available bandwidth. And we want tunnel 1 to basically have the priority over tunnel 2. And it's also said that tunnel 1 should not be preempted by other tunnels once established. Okay, so once the tunnel comes up, we want to make sure that sticks and doesn't get preempted. And here we must use the LSP attribute list for our configuration, and we have to observe the reaction of tunnel 2 when we have that, or make that adjustment. Okay, so just to plan a little bit here, so for tunnel 1 to preempt tunnel 2, tunnel 1 by default has a priority of setup priority of 7. So obviously we have to lower that value to have a priority, so we can choose something that's less than 6. So let's say we want to do a value of 5 for setup priority. And to prevent other tunnels from preempting it, then the best we can do is to lower or increase the priority value all the way to the value of 1. So that way, when another tunnel comes along, even with the setup priority of 1, it would not be able to preempt it. So our priority for new priority for a tunnel 1 in this case will be 5 and 1. Okay, so two things we have to adjust here, which is the bandwidth and the priority, and we're going to do that through our attribute list. So on R1, again, we do MPLS Traffic Engineering, LSP, attribute, let's call it TU1, and we're going to assign the bandwidth of 1500, and then the priority of 5, 1. Okay, now going back to tunnel 1, do a show run, let's do what we have. Show run interface, tunnel 1, and we no longer going to use auto bandwidth, so let's go ahead and delete that. Instead, we're going to do a attribute list as part of the path option 1, and that will be attribute TU1. Okay, give it a second, we show MPLS Traffic Engineering TU2. And since there isn't really enough bandwidth for the path option 1 of tunnel 2, which is the path option that has the bandwidth of 800K, it's going to have to fall over to whether it's option 2 or 3. Okay, it looks like somehow it fell all the way down to path option 3. So not too sure why it did that, but if you're trying to do, let's see, we can try to re-optimize that and bring it back to option 2, because option 2 has a bandwidth of 300, and it should always try to go with option 2 before option 3. So let's try to do MPLS Traffic Engineering re-optimize. Okay, let's take another look. You can see that it said re-optimization in progress, and now we are back to the path option 2, which is, see right here, 300K, and right now that tunnel 1 is going through router 3, 5, and 2. Okay, so after the tunnel 2 has been preempted by tunnel 1, it's able to find an alternate path based on the path option 2, and that is going through R5. Okay, so now instead of going through directly from R3 to R2, based on the option 2, we're now going through R5, and that's because the bandwidth for path option 2 is 300. And now if you look at the tunnel 1, just like how we said it, the priority for the tunnel is 5 and 1. And as I mentioned, the affinity value by default on the tunnel is 0, and that's why all the mask values are all 1, and that means that all the bits in the affinity values matters, so it has to be all zeros. And the path that the tunnel 1 is taking is still a direct path, which is going through R3 and R2, and the bandwidth is currently 1.5 meg. Okay, and again, the tunnel 1 was able to preempt tunnel 2 because tunnel 1 has a setup priority of 5, and then tunnel 2 has the hold priority of 6, which is a lower priority. Okay, so this is where we are currently.